A great day to one and all. I am Kim JC and Show, and today we are back for the discussion of licensure examination for teachers or LET review for mathematics majors set C. So I hope you are set for these 50 items and hopefully you will get them correctly. All right, let's have item number 1. In how many ways can 8 people stand around a flagpole? Is it 720, 5040, 40,320, or 8 raised to 8? So in this case, there are 8 people, and since they are going to stand around a flagpole, then it involves circular permutation, whose formula is the factorial of the quantity n minus 1. And since we have 8 people here, so our n is 8. And so by substitution, that's 8 minus 1 quantity factorial, that's 7 factorial. And when we speak about 7 factorial, that's the product of all the natural numbers or whole numbers from 7 until 1. And in this case, that's 5,040. Letter B is the correct answer. Number 2. In how many ways can the first, second, and third placers finish in a race participated by 10 people if there are no ties for any position? Is it 720, 5,040, 55,048, or 3,628,800? What do you think? So for this one, this involves permutation. The first, second, and third placers finish in a race participated by 10 people. And in the first position, in the first place, there are 10 people who are qualified for that. So that's why there are 10 slots for first place. If one of them already won first place, then that leaves 9 people for contention for the second place. And one of these 9 won second place. So there are 8 people who are qualified for third place. That's why you have 10 times 9 times 8, or 720. Or you could also utilize the linear permutation, that is 10 permutation 3, because anyway, there's no repetition here. And the formula is, in this case, we have 10 factorial all over 10 minus 3 quantity factorial. And the 10 factorial could be expressed by 10 times 9 times 8 times 7 factorial all over 7 factorial. I'm just until 7 factorial because I could cancel them in both numerator and denominator. And what's left in the numerator is 10 times 9 times 8, which is 720. Letter A is the correct answer here. I hope you got them correctly. Let's proceed to item number 3. How many distinct arrangements are there in the letters of the word Panama? Is it A, B, C, or D in this case? Now, for this particular case, you could see that there are repeated elements. And hence, we will be using the concept here of indistinct permutation, or let's say permutation with repeated elements. So from here, we could see that there's 1P, 3A, 1N, and 1M. And by that, since you have a total of 6 elements here or objects, then what we can do is we could divide the factorial of 6 with the number of times you repeated, or let's say the number of times a certain element with the factorial of the elements that come out, of the number of elements or objects that came out. So that's why we have here 1. There's 1P, that's why 1 factorial. There are 3 A's. That's why I have it over 3 factorial, 1N, so 1 factorial, and 1M, 1 factorial here as well. And in this case, in many instances, it's better if you could just not include the 1 factorials, because 1 factorial is 1. And if you divide any number by 1, that still the number itself. So this number becomes 6 factorial all over 3 factorial. The numerator could be factored as 6 times 5 times 4 times 3 factorial all over 3 factorial. So I will cancel this or divide them into 1. And what's left is 6 times 5 times 4, which is 120. Letter B. Number 4. Liz brought 7 shirts, 5 shorts, and 2 pairs of pants, 2 pairs of shoes, 2 pairs of shoes for a 2-day trip. How many outfits consisting of a shirt, shorts, and shoes can she select for the day? Is it 14, 16, 70, or 140? So in this case, to get the total number of combinations, all you have to do is utilize what we call the fundamental counting principle. And hence, we have to multiply 7, 5, and 2, and that gives us a total of 70 outfits consisting of a shirt, a pair of shorts, your shorts, and your pair of shoes. Letter C. Number 5. In how many ways can 7 people be seated in a row of 7 chairs if 2 of them insisted on sitting beside each other? 240, 720, 1440, and 2520. In this case, there are restrictions. We're talking about permutations with restrictions, and that 2 of them should be sitting beside each other. So in this case, let us presume that these 7 people are represented by A, B, C, D, E, F, and G. And let's say the 2 people who wanted to sit beside each other are A and B. That's why I boxed them, A and B here. And since they are boxed here in this case, they are grouped together. They are only counted as 1. So we have 1, 2, 3, 4, 5, 6. That's why we have 6 factorial here. And you might ask, where did the 2 factorial came from? Because these 2 people could still arrange in 2 factorial ways. And hence, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, or 720. And 2 factorial is 2 times 1, or 2. And hence, the total number of ways is 1,440. Therefore, if you answered C, you got it right. Next number, item number 6. A certain company demands that the PIN code of their employees consist of 5 characters. The first 2 characters should be capital letters from the 26 letters of the English alphabet, and the rest are digits from 0 to 9. If no repetition is allowed, how many distinct codes are possible? Is it A, B, C, or D in this case? You may pause the video if you wish and solve. And for this one, actually, this could be answered by simplifying 26 permutation 2 times 10 permutation 3. How come? Because the first 2 elements of your PIN code should be digits from your alphabet, and we have English alphabet, and there are 26 of them from A, B, C, D until Z, and you are going to choose 2 of them. And here in this case, there's no repetition, right? That's why we have used the linear permutation formula. So there are 26 permutation ways to select the 2 letters. And for the 3 digits, we know that it's from 0 to 9, and there are 10 digits. And you're going to choose any 3 of them without repetition. So that's 10 permutation 3. 26 permutation 2 simplifies to 26 times 25 times 24 factorial all over 24 factorial times the simplified, the value of 10 permutation 3 is 10 times 9 times 8 times 7 factorial all over 7 factorial. And with such, we arrive to 468,000 pin codes using these constraints or conditions. Letter A is the correct answer here. Number 7. 14 distinct points are evenly placed on the circumference of a circle. If any 5 points be connected to form a pentagon, how many distinct pentagons are there? Is it 1,059, 3,003, 40,320, or 360,360? So for this case, this is now a combination problem because the order here does not actually matter as long as you have a pentagon. And out of the 14 points, you need 5 points to form a pentagon. And since this is a combination problem, we will use the formula for combination, which is NCR equals n factorial all over n minus r factorial, r factorial. With your n equals 14 and r equals 15, we have 14 combination 5 equals 14 factorial all over 14 minus 5 quantity factorial times 5 factorial. This could be simplified as 14 times 13 times 12 times 11 times 10 times 9 factorial all over 9 factorial. The 14 minus 5 factorial, it's 9 factorial. 5 factorial means 5 times 4 times 3 times 2 times 1, which is 120. And we could divide both by 9 factorial. And you will be left with the product of 14, 13, 12, 11, and 10 divided by 120. And hence, the correct answer here is 2002. It's not one of the choices. That's why the correct answer is letter E. By the way, to our reviewees, in the instruction in our paper, if the correct answer is not found on the choices, you have to write E. So I hope you do not forget that. All right. Number 8. Section A and B have 10 and 9 student advocates, respectively. If 7 will be chosen for the conference, how many ways can representatives be chosen? If 4 and 3 representatives will be chosen from sections A and B, respectively. In this case, this still involves combination. And we will take the 10 combination 4 because the 4 will be taken from this 10 in section A. And 3 from section B will be taken from the 9 total. So here, we have 10 combination 4 times 9 combination 3. The order here does not matter. That's why we took combination. And besides, what's important is that they are there and without regards to order, and they, let's say, they have equal rank in this case. So by utilizing the combination formula I presented earlier, this simplifies to 10 factorial all over 10 minus 4 factorial times 4 factorial times 9 factorial times the factorial of 9 minus 3 times 3 factorial. And with such, you arrive to this expression. You could see from the first expression that the 6 factorial could be divided from both numerator and denominator. In the same manner that 6 factorial could also be divided in the numerator and denominator of this one. And what's left is this expression. I just copied it from here, but removed all the 6 factorials. And using your calculator, you should be able to get 17,640 ways in all. So letter D is the correct answer. I hope you got them correctly. Number 9. There are 20 people in a conference. If each one will shake hands with each other once, exactly once, how many handshakes will there be in all? What do you think? Is it 40, 150, 190, or 210. So this is again a combination problem. And remember that for every handshake, there are 2 people involved. That's why we have 20 combination 2, which is equal to 20 factorial all over 20 minus 2 quantity factorial times 2 factorial. The 20 factorial is factorable or could be expressed as 20 times 19 times 18 factorial all over 18 factorial times 2. So we could divide them both by 18 factorial. And what we have is 20 times 19 over 2, which is 190 ways. Hence, if you answered letter C, great job. But if not, just do your best for the succeeding items. Number 10. Rob would like to invite at least 8 out of his 10 friends to join him in his party. In how many ways can this be done? This is again a combination problem. So you could invite at least 8, meaning to say you could invite 8 out of 10, 9 out of 10, or all of them, 10 out of 10. That's the reason we have 10 combination 8, 10 combination 9, and 10 combination 10. And all we have to do is, since these are 3 different cases, then after getting the value of each combination, then we have to add them. 10 combination 8, by using your calculators, you could verify that. That's 45 ways. 10 combination 9 is 10 ways. And 10 combination 10 is 1 way. That's why we have 45 plus 10 plus 1, and that's 56. Letter A. All right. I hope you were able to do this on your own. If you forgot about the combination formula, you may go back to the previous slides, and I'm sure you will get the same answer as I did. Okay?